Let's go to the handout on page 264, and this would be the motion problem. And we're going to do the evens for now. So that's going to start with number 2. Now for motion problem, you need to read it first time to get an idea what it's talking about. Then after that, you need to go and read it one more time to draw the picture. So read it one time to realize, okay, this is a motion problem. So you need to do it one more time to draw a picture. Okay, so it says find the rate of 2 cars travel in the same direction. Okay, so you have 2 cars. Okay, traveling in the same direction. Okay. And one is fast and one is slow. Okay, so I'm going to make this fast. Again, you got to put all the information in there. And this one is slow. If they live at the same place at the same time, so same place, right? So same place at the same time, so write down all your information. So same place at the same time. The rate of one is twice as fast as the other. So this one r equal to 2x and this r equal to x. Now don't write anything between, because if you write it over here, you're not going to know if it's for the top or for the bottom. So for the top, you write above it. For the bottom, you write below it. So don't write anything in between. That way, there would be no confusion. Again, if you write in the middle, how you know it's for the fast or for the slow? You're not going to know, right? So again, keep the middle blank. Don't write anything over here so you don't get confused. Okay, so over here is 2x, and this one is x. And it says up to 4 hours, so that means t equal to 4 hours. And t equal to 4 hours. Again, because it says same time, right? And then it says the faster car is 80 miles further. So the fast car is 80 miles further. So this would be 80 miles right over here. Okay, so that's your picture. So now you have to make the table. So this is the fast, and this is the slow, and this is r times time equal to distance. Okay. So again, so now you're going to fill in the blanks. So fast car, the speed is 2x, the time is 4, and so this would be ax. For the slow car, the speed is x, and time is 4 hours, so this would be 4x. So after you finish the table, you need to go and figure out what is the relationship between these. Okay, your final entry is what's going to, that's indication that what you need to figure out. So look at this picture of it. You can see that the fast is equal to the slow plus 80. Right? Again, the fast, this is the fast, is equal to slow plus 80. So these two, you add this two equal to that. So most of the cases, they are equal, or you have to add something to, add them together. So there are some of the cases. So now let's go and substitute, right? So again, for the fast car, the distance is ax. For the slow car, the distance is 4x. So minus 4x on both sides. So you got 4x is equal to 80. Divide by 4, so x equal to 20. Now don't box it yet. You have to go back and make sure you answer the question. Okay, what are they asking for? It says find the rate of the 2 cars. So the rate of the 2 cars. So you're looking for these 2 blanks over here. That's what you're looking for, rate, right? So in this case, the fast car is 2x, so it would be 40 miles per hour. And for the slow car, it's x, so it would be 20 miles per hour. And that's done. Now let's go to number 4. Okay, so number 4, you read it one time first. So this is talking about airplane flight with the wind and flight against the wind. Okay, so you have the airplane over here. So you're flying and the wind is blowing, right? So this is with the wind. And then you're coming back. Okay, so you're going against the wind, but again, when you're coming back, the wind is still going this way. Okay, so that's your situation. Now let's go back and start to fill in the numbers. Again, all the numbers in the poem should be on a picture. So make sure you draw pictures because the picture is worth 2 points. and you need to have all the numbers on the picture to get the 2 points. So if you just do that, you don't get any point because there's no numbers on it, right? Okay, so flying with the wind, the airplane traveled 1,200 miles. Okay, so over here, so this total is, so the distance is 1,200 miles. And in 4 hours, so time equal to 4 hours. Flying against the wind, so distance equal to 500 miles, and the time is 2 hours. And you're looking for the speed of the airplane and speed of the wind. Okay. So speed of the airplane and speed of the wind. That's what you're looking for. So that's all the information. So again, you go ahead and make the table. So this is with the wind, this is against. Okay. So with the wind, it doesn't give you any numbers. That means if you don't have any numbers, means you use variable. So the speed, the speed of the airplane would be the airplane itself plus the wind is blowing, and the time it tells you is 4, and the distance it tells you is 1,200. Now for the against the wind, the speed, the total speed would be speed of the airplane, but the wind is blowing it back, so you have to minus the wind, and the distance is 2 hours, and the distance is 500. So in this case, your equation would be, so R times time equal to distance, so you have the P plus W times 4 equal to 1,200. For against the wind, you have the P minus W times the 2 equal to 500. Okay. Now, instead of distribute to make into mass, what you do is, again, you have to look at what you're doing. Don't just do things blindly. Okay? So this is going to be the elimination type of equation. So you can divide to lower your number. So divide by 4. So this will cancel out. So you get P plus W equal to 300. Do the same thing over here. Divide by 2. So this will cancel out. So you get P minus W equal to 250. So now notice the W already opposite, so you can put underneath already. Okay, I'm going to put this underneath here. So I get P plus W equal to 300. And you add, so this will cancel out, so you got 2P equal to 550. Divide by 2. So P equal to 275. Okay, and that's one of the answers you're looking for, right? So miles per hour. So that's one of the answer. Now to look for the speed of the wind, you can use either equation. This would be easier to do. So let's go and substitute. So minus 275. So W equal to 25 miles per hour. Okay, and those are your two answers. So you can make sure you learn the technique and apply it each time as you go. Okay, now let's go to number 6. Again, read the problem. So this is the motion problem. So you have two trains, one going north, one going south. Okay. Okay, so let's read. So it's a southbound train traveled for 2 hours, and means the northbound train has been traveled for 4 hours. So the two trains start from city 300 feet miles. Okay, so you have one. So this is the south, the one going south, and this is the one going north. Okay, and it tells you that the southbound train traveled for 2 hours, so T equal to 2 hours. Again, so when you're doing the especially motion problem is the hardest problem. So something you have to read it several times. You have to read it four times, 5 times. Do whatever you have to do. Right? The northbound train, the time equal to 4 hours, and they started 350 miles apart. What is the speed of each train if the northbound train is 10 slower than the southbound train? So this one is equal to 10 slower than that. Okay. So again, so this is 10 slowest, means 10 less than that one. Okay. So again, the second train would be your reference. The second item is your reference. So now this is your picture. Now you make the table. So R times time equal to distance. So this is the south and this is the north. So southbound train, the speed is x and the time is 2, so distance would be 2x. The northbound train, the speed is x minus 10 and the time is 4 hours, so this would be 4x minus 40, right? You just multiply. So now you have to figure out what's the relationship between these two distances. Well, if you look over here, right, so south plus the north equal to 350. I see over here, the south plus the north equal to total 350. So you substitute, so you got 2x plus 4x minus 40 equal to 350. So simplify, you got 6x minus 40 equal to 350. So go and plus 40 on each side to solve. So 6x equal to 390. Divide by 6, so x equal to 65. Now don't box it yet, you have to go back and answer the question. It asks you to find the speed of each train. So you're looking for these and these. So for the southbound train, it's x, so it's 65 miles per hour. For the north, it's x minus 10, so north is 55 miles per hour. And those are your answers. Okay, so let's go to number 8. Again, read the problem. So you have so a plane leaves Little Town Airport and travel east, and the second plane leaves later and travel west. So you got two airplanes going opposite direction. Okay. Okay, so let's go and draw a picture. So this is the airport. So first one travel east. So this is going east. So R equal to 230 miles per hour. And the second one leave 3 hours later and going west. And so over here, now you have to write all the information. So this is 3 hours later. And the R equal to 215 miles per hour. So you can make sure you got all the information on here. Okay? So how long has each plane flown? So you're looking for T. How many hours, right? How long has each airplane flown when two airplanes are 135 miles apart? Okay, so that's your picture. Okay, so now let's go and make the table. So R times time equal to distance over here. And so over here we have the west and the east. Okay, so let's go and start to fill in the blanks. So for the west, the speed is 215. The east, the speed is 230. Now for the time, this one is 3 hours later. Okay, and so that means this one is 3 hours earlier. So you can, if you use this as x, this would be x plus 3. If you use this as x, this would be x minus 3. So you can do it either way. Okay, and personally, I don't like the negative, so I'm going to make this as an x. So the time for the west would be x, and this one is 3 hours earlier, so this have 3 hours head start, so it would be x plus 3. Okay, so again, if you use this as x, this would be x minus 3. So you got to figure out that part out. So now let's go and add multiply. So you got 215x multiply. You got 230x plus 690. So now you have to look at the relationship between the two. Okay? So again, if you look at the picture over here, the west plus the east equal to 1135. So you substitute. So you get 215x plus 230x plus 690 equal to 1135. Combine the like terms, so you get 445x plus 690 equal to 1135. So minus 690 on both sides. So 445x is equal to 445. Divide by 445. Divide by 445. So x equal to 1. Okay, but don't pass it yet. He asks you to find the time for each airplane. So you're looking for this one and this one. So by looking at that, so the one going west equal to 1 hour. The one going east, so it's x plus 3, so it's 4 hours. Okay, and those are your two answers. Those are your answers. Okay, let's go to number 10. Okay, so you can read the problem. So you have a train leaving the city and heading east, and another train traveling east. So both are going in the same direction, but one goes ahead of the other. Okay. Okay, so let's do this one over here. So let's call this one the first train. So the first one, it leaves at 11 a.m. and heading east at speed of 38 miles per hour. And you have the second train, leaves at 2 p.m. and travel east at r equal to 53. So it's faster. And it says how long, it means how many hours will it take the second train to come within 54 miles of first train. So you try to catch up. So how long will it take to come within 54 miles? Okay. So that's the picture. So you don't know the time, right? And I'm going to, since you're looking for the time for this one, I'm going to make this time equal to x over here. Now this one has 3 hours head start, right? See over here, so that's, you have to use this clue to figure out the time. So if this is x, the time over here would be x plus 3, because this has 3 hours head start. So that's the picture. Again, make sure you read and understand the problem so you can draw a picture. If you cannot draw a picture, means you are not understanding the problem. Okay, so you need to understand the problem to draw the picture. So this is the second train. So you can r times time equal to distance. So the first train, the second train. So the first one, the speed is 38. The second train, the speed is 53. The time, this one have a 3 hours head start, so it'd be x plus 3, and this one would be x. So when you multiply, you get 38x plus 114, and this would be 53x. Okay, so now by looking at this picture, you got to look at the relationship between them. You can see that the first train equal to s plus 54, right? Can you see that? So this is equal to this plus this. So that's your equation based on that. So now you're ready to substitute. The first train is this over here. So you can substitute. So you got 38x plus 114 equal to the second train is 53x. Okay, so now let's go and try to solve this. So let's go and move the variable to this side. So minus 38x. So this will cancel out. And we want to move the number to the opposite side. So minus 54, minus 54. So this cancels out. So you get 60 equal to 15x. So divide by 15, divide by 15. So x equal to 4. Now you have to go back and read the problem to make sure you find out what are they asking for. It's how long will it take? So how long will it take the second train? So that's all you're asking. That's what you're looking for. So that's it. So 4 hours would be your answer. Okay, let's go to number 12. Okay, number 12, it says 2 trains leave the station at the same time. One's going north and the other one going south. Okay, so again, here's your train station. So one is going north, north is up, and one is going south. Okay, and at the same time. So again, this is very important information. So make sure you write down all the information. So same time. Okay, the express travel 14 miles faster than the local. So it doesn't tell which one is which, so it doesn't matter. So let's go and call this express. Okay, and this is local. If it doesn't say, it doesn't matter which one is which. So express, and it says it's 14 miles faster. So that means the speed is x plus 14, and the speed over here is just x. And it says up to 3 hours. So again, same time, right? So t equal to 3 hours. And so this one, the t equal to 3 hours. So after 3 hours, they are 315 miles apart. So it is 315 miles apart. Okay. And so you're looking for speed of each train. So again, let's go and make the table. So r times time equal to distance. And so this is the express, and this is the local. So express, the speed is x plus 14. The local is x. The time is 3. The time is 3. So you multiply, you get 3x plus 42. This one you get 3x. Now you have to write the equation, you have to look at the picture. By looking at this picture, you can see that the north plus the south equal to total of 315. Right? So now you substitute. So for the north, it's the express. So this is the north, this is the south. Okay, so they're interchangeable. So this one is 3x plus 42. This one is 3x. So now you work it out. So you get 6x plus 42 is equal to 315. So minus 42, you get 6x equal to 273. Divide by 6. So this one that doesn't come exactly, but that's okay. So you just use your calculator. So 273 divided by 6 equal, so you get 45.5. Okay. But don't pass it yet. You go back and make sure that you figure out what they're asking. It says, what's the rate of each train? So you're looking for these and these. Okay. So in this case, the express is equal to x plus 14. So you have to plus 14 on that. So it gives you 59.5 miles per hour. And the local is equal to x, so it would be just 45.5 miles per hour. Okay, and that's it. Okay. Again, so you need to know the technique and apply it, and to do that every single problem.